Chase Y the forest guy. Chase Y the forest guy.
Chase, 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 chase.
Chase Y the forest guy.
With Kyle.
Forces. Cut the camera. Chase Y the forest guy here for soccer, the most popular sport in the world. How are forces related to soccer? You're about to find out. Newton's first law simply states that an object at rest will stay at rest, and an object in motion will stay in motion at a constant speed in a straight line until acted on by an unbalanced force. That means that the soccer ball will stay at rest until acted on by an unbalanced force. In this case, the player's foot. It will continue to roll until in a straight line at a constant speed until acted on by another unbalanced force. In this case, being the grass.
Newton's second law, the acceleration of an object depends on the mass of the object and the amount of force applied.
The equation for this is A equals F divided by M. For example, if a soccer player kicked the soccer ball with a force of 20 newtons and the soccer ball weighed 436.5 grams, the acceleration would be 0.05 meters per second squared. On the other hand, force is equal to mass times acceleration. For example, if the soccer ball weighed 436.5 grams times 0.07 meters per second, it would equal 31 newtons. The speed of the soccer ball is equal to the distance traveled divided by the time it takes to travel that distance. In this case, the distance is 2 meters. We're about to find out how long it'll take.
I like those words you used. Good word choice.
0.95 seconds. Speed is equal to distance divided by time. So in this case, speed is equal to 2 meters divided by 0.95 seconds, which is equal to 2.1 meters per second. To get velocity, all you have to do is take the speed and add in a direction. So for this, we'll just say that it was 2.1 meters per second forward. The soccer player can control the speed of the ball and the velocity by changing how hard they kick it and in which direction they kick the soccer ball. Momentum. 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 Momentum is equal to mass times velocity, or P equals M times V. For example, the momentum of the soccer ball is equal to 436.5 grams times 2.1 meters per second forward to get 916.7 grams times meters per second forward. Newton's third law states that whenever one object exerts a force on a second object, the second object will exert a force that is equal and opposite on the first. An example of this would be your foot on the ball and the ball back on your foot. Go. Another example of this would be the ball on a tree and the tree back on the ball, causing the ball to rebound.
Okay, so Newton's three laws help better me as a soccer player by when I dribble, if I add more force to the ball, when I'm dribbling and there's a defender, then they can steal it from me like this. But if I apply less force to the ball and gain more control of it, I can easily dribble around the defender.
Knowing Newton's third law can give him an advantage in his sport of soccer. When the ball comes in and hits my head, that's the action force. The reaction force would be the ball bouncing off my head. And an effect of this would be my head hurting. Here's an example. And it goes to one of the players. What we did in class that connects to soccer would be the balloon rocket lab. In this lab, we propel the balloon on a fishing line across the room. The more mass we added, the less distance the balloon traveled. This applies to soccer because when you have a soccer ball a small soccer ball and a big soccer ball and a small soccer ball, the bigger one will go less of a distance than the smaller one when applied at the same force. Here's that concept in action. It's going to take a force to move this. And this. And it's certainly going to take a force to move this. You see, forces are needed to do just about everything. May the force be with you.